Hello everyone, I'd like to talk to you about studio automation and playouts.
Let me see this.
It's a loyalty oath to America.
Are you now, or have you ever been?
It was a joke at first. Moreau signed it.
Marlowe signed it? If you don't sign this, are you and I a target?
If I don't sign it, they'll fire me.
And seconds. Ready on camera, then.
Good evening.
Any man who protects communists is not fit to wear that uniform.
You can't convict people by rumor and hearsay and innuendo.
Are my children going to be asked to denounce me? Are they going to be judged on what their father was labeled? I see a chain reaction that has no end.
Charges were in a sealed envelope. Nobody saw them.
Wouldn't you guess that the people who have seen the contents of that envelope might have a better idea of what makes someone a danger to his country? Or do you think it should just be you that decides?
Who are the people? Are they elected? Are they appointed? Is it you?
I've searched my conscience, and I can't find any justification for this.
Our next show is going to be about Senator McCarthy. We're going to go right at him.
We will not walk in fear one of another. This is no time for men who oppose Senator McCarthy's methods to keep silent.
Mr. Edward R. Murrow has made repeated attacks upon me and those fighting communists.
Somebody's going to go down.
You're going to get audited this year.
Not me, you.
McCarthy wants April 6th.
I will not be deterred.
He's going to come after me.
You understand the position you're putting us in?
Let's walk very carefully through these next few moments.
Why don't you just fire me, Bill?
Go after Joe Kennedy. We'll pay for it.
Murrow is the symbol, the leader, and the cleverest of the jackal pack, engaged in propaganda for communist causes.
Okay, fellas, here we go.
We might as well go down swinging.
We're going to go with the story, because the terror is right here in this room.
10 seconds.
5, 4, 3, 2.
We cannot defend freedom abroad by deserting it at home. Good night, and good luck.
The movie Good Night and Good Luck shows us the internal workflows of TV in the 50s beyond its thrilling screenplay. It recreates the inside of a studio program realistically during the beginning of mass media. Any current professional watching the movie would be shocked about what these teams achieved with workflows that often implied many tools, different manual processes, and coordination between departments.
Hey, welcome to TV2 Nord. I'm just going to reload the rundown here, and we're going to have a look at automation here in the gallery. So you can see I've one button push there. I've started the automation off. You can see this is now playing the sponsor for the news show, ET. At the end of this, in the rundown, it will step into the next event automatically, which will be the sponsor of the weather. You can hear the automated countdown.
Nowadays, the studio workflows are automated and monitored by specialists that have everything under control. Currently, there is no need for the editor to lay on the host's feet to pass the information, and we don't rely on videotapes to control our rundown. Everything is digitalized, scheduled and automated from the same room.
Okay, and now there's no one in the gallery here, so actually this is completely automated, this process. We're now into the next queue. That's the sponsor for the weather. Now, the weather is done in Odense on a directly sent by an FTP transfer. So we've gone into the sting for the weather here. And here's the weather. So this is actually sent from Odense's TV2 HQ. They record the weather for them every day, and an FTP harvest actually picks that up automatically and brings it into the system. So if we have a closer look at the rundown here, you can see the white lines are the manual queues. Where we have black lines between queues, that means they're automatic. So everything so far is automatic. It doesn't need any human intervention. At the back there on the monitor wall, that's the output of the A10 multi-viewer, and then we've got the rundown on the right, and on the left the script is open and it's in follow mode, so it's following what's going on in case a producer who isn't here, as you can see, needs to make a change to a capture method. And there on the far right is the shot box, so you can punch things on and off with the touch screen directly there. And underneath that we have a small audio desk, which is controlling the main audio desk, but again that's all fully automated. So let's step out of the weather into the weather bumper. Again, automatic, no human being involved. And then into the sponsor coming out of the weather. And from here, we'll step into the opening titles of the news. Off we go. And again, all from one button push this. And at this point, we're live in the studio and we put a caption up automatically. So this is the first time actually that the producers and directors actually start directing the show. Now, they do a little summary at the start. If I just push this button, 1Q does the overlay graphic, and then we're on a little voiceover with the graphic. And it's really funny this, because it's a bit like a video game. This voiceover here will just loop and loop and loop and loop. So to move on, you just push take next again, and you get a little blue, and another VO and a graphic. And again, this just loops and loops and loops, and this just keep pushing until you've gone through all of them here. And then when you're done, it comes straight back to the studio. Super cool, super automated. And that's the automation here at Nord.
Essential elements for studio automation. Everyone will agree if we say that it's impossible to broadcast any program without a studio automation system. But which elements are essential in this kind of solution? We answer this question below with 4 keys. 1. Integration with other solutions. 2. Ability to optimize resources. 3. Complete control of studio audiovisual elements. And finally, flexibility and accessibility. TV production doesn't depend on a single solution, operator or editor. This process involves multiple systems that are entirely digitalized nowadays. From media graphics to engage the viewers to the modern newsroom solutions that allow journalists to be on the cutting edge of current events. It's useless to have a state-of-the-art studio automation system if it doesn't allow integration with other tools via mouse protocol, DXF and other traffic protocols that enables different studio elements to communicate between them without installing specific drivers. An evolving protocol for communications between newsroom computer systems NCS and media object servers or mouse such as video servers, audio servers, still stores, and character generators. This protocol is supported and developed through cooperative collaboration among equipment vendors, software vendors, and end users. Our goal is to develop and maintain a common communications protocol which allows integration of diverse NCS and mouse equipment.
All the content required to air the story, including teleprompter text, voiceover, graphics, and video content. Studio CG provides a solution for both video and graphics requirements. All the systems in the newsroom normally talk to each other through the MOS protocol, or call-out, so different vendors of different components understand each other in the distribution and synchronization of this content to its final destination. These components may be a video server, a teleprompter, or a CG engine, among others. For MOS to work, both the NRCS system and each peripheral system normally have an MOS gateway component. WT Vision's MOS gateway receives orders from the NRCS and synchronizes the Studio CG rundown in real time. In order for a journalist to add video and graphics content to their story, WT Vision provides an NRCS plugin that gets installed in the NRCS. Calling this plugin will show available graphics templates that have been imported into the system. If, for example, a journalist wants to add a lower third graphic to her story, she calls up the plugin and chooses the lower third template. The corresponding form appears and she can fill it out. To make sure everything fits snugly, she would like to see what the graphic will look like when it goes on air. Enter Studio Preview Server, a component that requires many journalists to share a graphics rendering component to provide a pixel-perfect rendition of the final graphic without having to own an expensive graphics workstation. If she is not happy with the result, she can iterate this process as many times as she wishes. When adding video, you can search for it in WT Vision's Media Asset Manager, which locates all media available in the network under its scope. You can view a low-resolution proxy for easy browsing. After locating the video you require, simply send it to the story. After MOS communicates these actions to Studio CG, it will in turn ask the MAM for a media transfer to its final destination, if not already there. This happens automatically with no user intervention. You can also time graphics to video for fully automated story playout. After clicking a video, you can drag graphic templates to the timeline and adjust their in and out time codes. The low-res video will allow you to pick the right moment for each graphic. When this story reaches studio, taking the video will automatically take the associated graphics in and out at the appropriate times. The NRCS workflow is available for multiple industry-leading vendors, with more being continuously added. If your workflow requires rendering graphics into your video stories permanently, it is likely you want to do this upstream in your non-linear editor. Studio CG provides a similar workflow for this using its NLE plugin, which we will cover in a separate video.
BXF was developed to replace various archaic types of exchange for playlists, record lists, and other data in broadcasting. Version 1.0 was published in 2008. Over 150 SMPTE members have been involved in defining the standard. BXF is XML-based. For more information about MOS and BXF, refer to Video Systems in Init Environments book. Let's go back for a moment to the movie example, in which we see how the studio management workflow is full of different profiles and manual processes. Nowadays, the resources are set and optimized thanks to the studio automation systems. We can broadcast any show or news program with an operator and an editor. Therefore, the studio operator must count on a system with all the necessary tools for professional production, such as previsualization of content clips, frame-by-frame advance, loop, cue preview, next and previous, fast forward, rewind or timeline. Not only that, this software must be flexible and adaptable to the professional's needs. TV studios' appearance experienced a notorious advance during its history. In the first place, we saw how multiple complementary TV screens appeared behind the hosts. Nowadays, it's usual to see large audiovisual panels in the studios, visually supporting the information, projecting the show's logo or playing loops. These new features trigger workflows that our studio automation system must control to produce a professional TV show. The studio automation system manages multiple rundowns in parallel, controlling up to 4, 8 or 16 channels in list mode and allowing control of 16 additional video server channels. With these video servers, we can broadcast different contents from the program's playlists on the studio plasmas and provide visual support to our broadcasts. And finally, flexibility and accessibility. Any program rundown can't be unflexible or untouchable. Far behind are those times in which the operator received an unchangeable playlist. Nowadays, the rundowns must be open to changes and be accessible for different professionals once the news events knock on the door. Let's imagine a piece of breaking news that destroys all our previous content playlists. With this situation, our system must allow access to different NRCS users to introduce changes from the newsroom and send them in real time to the studio automation, operating in a fully collaborative way with the program's playlists. Furthermore, we might also need to create a new and different rundown in a short period to substitute the original. Therefore, it is essential to work offline in this version and then replace it in the studio automation system. Well, that's about it for this part. We've covered essential elements for studio automation. Let me elaborate further on studio automation components. Now I've decided to do this to explain what the studio automation is all about, give you some ideas perhaps, how it can be used to explain the thinking behind it a little way and then show you the possibilities of what can be achieved with it, and it's going to be a nice straightforward presentation here. So just check this out the way so I can see what I'm doing. So 2 parts. We're going to be talking first, or I'm going to be talking, and then very brief demo afterwards. This is going to be quite a short one today, but we should get all the relevant points covered reasonably easily. So for start off, then everybody is confronted with trying to get the best quality television working with the most efficient spend of the money. Basic broadcast needs are there, and there are products out there that offer broadcast services but don't necessarily cover those basic broadcast needs. So we'll be talking about those broadcast needs. We'll be talking about how we've met these needs in the past compared with how we're doing it today. And we'll look at what else we offer that meets those broadcast needs that will focus us in on the studio automation, at which points I can explain what the studio automation entails, what it contains, and talk about some configuration possibilities. And we'll have a very quick look at a real-world studio automation. that's out there right now. So the basic broadcast needs number one is reliable. Reliability is very important in basic broadcast needs. Maybe not a basic need, but it's something that's very useful, is being able to record your input for delayed broadcasting, for rebroadcasting of what you've already transmitted, even for compliance. And so that's a nice thing to have. Also, it's pretty useful if you're broadcasting to be able to put your identity out and make people aware of what they're watching, keep them up to date on what you're going to be showing, and so on. So graphics and branding are quite important. And then you also need to be able to see what it is that you're doing and how well you're doing it. And for that, it's very good to have monitoring. And sometimes people send you stuff to put on the air, perhaps commercials, perhaps clips, who knows, that simply don't conform to any standard broadcast standard that we can read in air. And so therefore you might need to transcode. And then finally, the other way that you could be absolutely sure you've been sent something good is if you can play it on a player that is aware that it is broadcast quality, and will show it in broadcast quality with broadcast quality support tools for quality control. So these are all basic broadcast needs, and we've thought that we would be able to offer something in that metal. In the TV automation IP-based workflow, automation plays a significant role, and the term orchestration can be used to describe a larger use of automation across multiple and diverse systems and devices. Introducing this level of automation changes the workflows at each production and technical operational process. Automation is more than just playout. Automation manages the movement of media throughout the infrastructure. Systems monitor other systems waiting for media to arrive. Once the media appears in a folder or as a stream, automated processes recognize its arrival and trigger the next event. This could be an encode, transcode, or QC process, or it could alert a producer or editor that there is media available for editing. The digital library is alerted that new media is in the system and to check metadata. The quality control tools monitor incoming content locations and begin testing the integrity of the media and metadata. Moving media requires rules and policies and systems to manage them. In the enterprise industry, these applications are called business process managers, or BPM, and they control the movement of files, the integration of databases, and the interaction between applications sharing data. In the broadcast IP infrastructure, these systems are called conductors or orchestration applications. One of the key differences between enterprise and broadcast stream and file management is that in enterprise the documents and data do not move throughout different processes and applications. A Word document stays with word processing. The spreadsheet is not converted back and forth between applications, and data sets that may be shared by multiple applications don't change in structure. In broadcast architecture, media and metadata moves and changes as it travels between different applications and processes. There are stream and file movers and data directors. This is where orchestration becomes a critical piece of the puzzle. As the media enters the system, it needs guidance to go from the originating source through acquisition to ingest and production, getting coded and registered to the media management system, possibly transcoded and converted before being moved to the appropriate storage location. The same way we use different expressions for media management depending on where in your media supply chain these media management tools are applied, the same idea applies to video production workflows in general. To some extent, they all contain the following processes: media acquisition, editing and collaboration, media management, and media delivery and distribution. However, The requirements for video production workflow steps can look a bit different depending on the type of user environment. A news workflow or journalistic workflow differs from the traditional broadcasting workflow or the post-production workflows found in feature film creation and commercial film workflows. What is video post-production workflow? The expression video post-production workflow refers to a workflow process starting after the actual film or video recording on set or location. There are many types of productions, from feature film to commercials, documentary, reality shows, but they all require a video post-production workflow of some kind to manage the creative and collaborative process that will produce the final products. Another word for this process is also media ingest. To manage incoming media files is one of the more challenging tasks. In a video post-production workflow, the more successful you're here, the better and more efficient the editing and collaboration process will be. First of all, the media itself needs to be stored with the logging or descriptive information about the content itself. Traditionally, we have used logging personnel to quickly navigate the information about the content from the script supervisor. Instead, today time code or frame-based descriptive metadata can and need to be applied over the media duration as well. For example, this means that a person or environment that occurs several times in a clip now also can be defined at these time codes. In a media logging ingest workflow, time code-based logging metadata becomes a valuable addition to the global-only metadata. Such data plays a key role both in quality control and compliance, but also in making media reusable and searchable. While in the past adding this frame-based metadata has been a manual task, there are now an increasing number of video analysis tools and video production workflow software that partly or fully automate this process. Many of these take advantage of machine learning algorithms and detect content such as objects, faces, environment, explicit language, violence, and contexts. In standard workflow, you can easily attach cognitive services and evaluate the result throughout the video post-production workflow. After a successful logging process of source media, we are ready for editing. Editing has multiple steps, and depending on the focus, size, and structure of the organization, as well as the skills focus of the users, different tools may be used at different stages. The first stage would be collection. Here we are interested on finding our clips, or the parts of clips we want to use, and collecting them together so that they can be sent into the edits. This may be done directly in the editor, but in larger enterprises can also be done through other user interfaces. Applications such as our media portal allow users to very quickly and intuitively search for and view clips, marking the sections of those clips they want to use and adding them to a shopping basket-like bucket to become a collection. These collections can then be shared with other users or sent to an editor. Once in the edit, there are two further stages which, again, can be achieved in one or two separate tools. This first stage is the rough cut or simple edit. Here the clips from the collection are assembled together in the final order that we want. We may also add some simple transitions between clips, add a voiceover, or start adding graphical overlays if needed. All this can be done in a simple browser-based video editor or in a craft editor such as Adobe Premiere Pro. In some fast turnaround workflows, such as current affairs, content may be published directly from this stage without going to the second stage. In the second stage, we move to the craft edit. In this stage, the edit is refined with further effects and video processing added to create a high-quality final output. With the Edit Make panel integration in Adobe Premiere Pro, the editor has instant access to any part or collection of clips necessary to tell the story. The editing process is rarely a one-person job. Several editors can be involved in the same project and producers, and sometimes customers need to get daily updates on the process. The PAM system speeds up these processes by keeping track of media projects, sequences, versions, and associated metadata. As a part of the collaboration process in a video post-production software, proxy versions of the source media, as well as sequences, are made available for review and approval. The PAM system will also track and manage the parent-child relationship between source and proxy media to make editing and search in the cloud possible with editor and media portal. Let me use a video to explain audio-visual post-production workflow.
Hello and welcome. In these videos we'll be looking at Content Agent's deep integration into Avid editing products. So whether you're running a single media composer or a part of a huge interplay deployment, you'll benefit from the advanced bi-directional workflows that are available. Let's start afresh by making a new workflow that will integrate into a standalone media composer. The goal here is to automatically prepare clips into an Avid-friendly format and then put them into the Media Composer's Managed Media Directory structure. Once we've built the workflow, we can use Card Agent to easily submit camera card and other file structures to it. We'll start with a blank canvas in the Workflow Designer just to give you a better idea of how simple it is to construct automated ingest pipelines for Avid. I'll add a metadata extract node first to propagate clip data downstream. Content Agent by default preserves all clip metadata throughout the flow, and as we'll see later, we can also further utilize external metadata as well as creating completely custom metadata that can be used to drive other functionality. As the source for this workflow is coming from a camera card, I can use a Reel Splitter node to better optimize parallel processing of the clips within the card structure. After this, we'll introduce something that we use extensively within the pipeline, a versatile tool called the Decision node. Now this node has so many applications within a workflow, allowing us to branch pipelines based on metadata. But in our example, we're going to use a very specific option that allows us to see if a particular file type can be rewrapped into an Avid optimized format rather than having to transcode it. If it can, we then pipe this branch into tools that will rewrap the files into OP-Atom MXFs. Then write those files directly to the Avid Media folder, and in a standalone Media Composer environment, also update the database simultaneously. We even have the option to wrap and join clips into a new single piece of media. If the files can't be wrapped, then from the other output we can route them into a Platinum node to physically transcode the clips into OP-Atom MXF files. When we drop the node into the flow, it opens up the template browser, and we can see that we already have some system presets for Avid. I'll choose one of the higher bitrate codecs for my full resolution. When the Platinum interface opens, I'm going to adjust my preset to match my original frame rate. Now both the Avid OP-Atom rewrap and in this case Platinum nodes are configured to create an AAF as an output. We'll look at how these will be used in a moment. I'm also going to toggle on Use Platinum Codecs, which will give me accelerated transcode performance compared to the default processing. As before, with the Avid OP-Atom tool, the Platinum node can also write the MXF file straight into Media Composer's managed file structure and update its database at the same time. There is also the option to transcode and join clips as we could in the rewrap process. Now this is the location that the AAFs, which are generated and passed on into the workflow, will reference. By adding ReelMaker and AAF merger nodes, we can actually consolidate all the clips AAFs into a single one and at the same time create a new Media Composer sequence that will automatically load and join all of the source clips together into a timeline. I'll just repeat the process of building this and choose a proxy preset to generate my offline media for both of those branches. Finally, I'll add network copiers to write the AAFs to locations on the network. I'll specify high-res and proxy folders to keep them both organised. So just to recap, this workflow will automatically detect and filter media that can be quickly rewrapped or may need to be transcoded, then generate online and offline media and get everything into Media Composer ready for the editor to start work. As part of this process, we can also easily populate columns in the media bins with metadata from the clips or create new custom columns. To do this, we'll use a metadata injector node from the tools bin. Now for a quick example, let's populate the comments field and create a new column in the bin. We can use a metadata trigger that will prompt the data wrangler or edit assistant to enter some words into the comments column when submitting the media from Card Agent. We'll also make a new custom column that gets populated with the operator's name who ingested this media. Now that the workflow is complete, I just have to submit a card to be processed. Card Agent is our streamlined submission application that allows non-technical staff to easily browse media and then launch a pre-built workflow to process those files. Here we'll browse to some camera cards, view the contents, apply custom trims if needed, and even bulk rename both clips and cards. All of the changes we make here are populated into the selected job pipeline. Picking the workflow we just made, we can see that we have to complete the 2 custom fields we generated with the metadata injection node before we can submit the camera card. After the job is completed, we'll go into Media Composer and see how we access the footage. I've already set up my project and created a new bin. As all of the rewraps and transcodes from Content Agent are already in the managed media directory, all I need to do is simply import the AAF files that were generated. As Media Composer's database was automatically updated, there's no rescanning needed. I can even have Content Agent push files into Composer whilst it's open so I can carry on editing while media is being ingested. I'm going to browse to my proxy folder and import the AAF that references all my sources. Now remember that this AAF also contains a new sequence that was created by Content Agent. I'll quickly do some trimming and add a few dissolves. Now that the edit is complete, I can simply create a relink to the high-res media, again by importing the necessary AAF and then pointing the sequence to the new media. Now at this point you would probably then export the sequence to a master format required by the next step of the production pipeline. But instead we are actually going to offload this task back to Content Agent. We can do this by actually installing selected workflows directly into Media Composer's Send To menu. I've made this very simple workflow that will make my main deliverable formats, viewing copies, and then deliver these both to network locations, FTP and WAN services. Now of course these delivery workflows can be much more involved, including automated file QC, emailing of reports, and once again using rich metadata, move files to passed or rejected folders using decision nodes. Once we have the workflows that we'd like to make available to the operator, it's a simple case of using our template editor to create the Avid compatible package, and then the installer app to put the workflows into the Send To menu in each Media Composer. Back in Media Composer, it's a simple task to right-click on our sequence and then browse the required workflow and submit the timeline. Content Agent will pre-flight the task to make sure that all the required assets are available and then send the sequence to the job agents for processing, thus freeing up Composer's interface and allowing the editor to continue with other tasks. Up till now we've been looking at a typical standalone Media Composer environment, but the amazing thing is that with the addition of a few specialised nodes and settings back in the Workflow Designer, we can apply this pipeline to interplay PAM ecosystems as well. So let's have a quick look at how this can be achieved. Back in Content Agent, we'll make a duplicate of our last workflow and then modify it to work in an interplay environment. Now if you think about it, essentially our workflow will be very similar, except we need to write the media files into the Nexus storage and check in those clips into the interplay server. So firstly, let's delete the existing network copiers and replace them with interplay check-in nodes. As you can see, we're able to browse the connected server folder structure and either select an existing directory or dynamically create new ones based on clip metadata, say for instance the date or card name. Once this is done, we just need to modify the storage paths in both the Avid Opiatum Rewrap and Platinum nodes to reflect the location of the Nexus volume we are using. In both these nodes, we also have specific options for when working in an interplay environment. We'll uncheck our original settings to update a standalone Media Composer database, as this is no longer required, and enable the Do Multi-Res and the Edit Whilst Rewrap or Transcoding options found in these nodes. Do Multi-Res allows us to easily take advantage of Media Composer's dynamic relinking feature, which can associate two or more different resolutions as being the same clip. This makes for an easy toggle between offline and online media quality. Edit Whilst Rewrap or Transcode allows the editor to start working with clips in Composer even before the entire media duration has been fully processed. Now that we've made our changes, let's submit a camera card again and look at the result in Media Composer. But before we leave Content Agent, let's look at yet another interplay specific workflow feature. Jobs in Content Agent can be triggered in various ways. We've already seen how Card Agent can submit media, for example. However, we also have the ability to set up watch folders that are linked to specific workflows, so that whenever media is copied or dropped into them, it will trigger a particular process. The great news is that we can monitor interplay folders in the same way, so that when an editor drops a finished sequence into a particular directory, Content Agent will launch a specified task. As you can see, interplay watch folders are super easy to set up with just a few clicks. Just pick a workflow, then select a folder on the server. Saving this then activates the monitoring process for the new watch folder job. So now we'll be working in an interplay enabled Media Composer project. But first, let's look at our Media Central panel. As you can see, all of my clips have been checked in successfully to the server. If we now go back to Media Composer and bring up the Interplay browser window, we can drag in some of the clips and build a new sequence. As you can see, because we generated dual resolutions for each clip, it's simple for the editor to toggle between the different qualities using the dynamic linking button rather than having to manually relink to online clips in another bin. What we've seen in these examples are huge time savers and workflow enablers when it comes to collaborating with Avid Media Composer and Interplay ecosystems. So anything from a small editing or post environment with just a few Composer seats, right up to massive news broadcast deployments involving Interplay servers and tens of Media Composer suites can benefit from Content Agent. Content Agent should be your go-to solution for anyone wishing to accelerate and automate their Avid workflows to the next level.
During the video post-production workflow process, media needs to be prepared for editing. Master versions need to be archived and distributed. Storing a master is not only about storing a media file with metadata. Many times, storing the actual project might be much more useful since watermarks, graphics, and audio might need changing in the future. At the end of the video post-production workflow, multiple versions of the finished media need to be delivered. Most likely, we will see a final master format with the correct metadata schematics depending on the VOD platform. Most content partners have their own delivery requirements for metadata specifications. Also, the actual audio and video technical quality standards have to be verified and approved by each content partner before the video post-production workflow is complete. This, of course, also applies when delivering for traditional broadcast distribution. The media management system needs to be able to deliver the correct metadata and preferably orchestrate the process of media mastering as well to track this part of the media supply chain. Within file-based production workflow, files need to be accessible to various applications and processes and possibly need to move between storage locations. All of these processes are applications on servers, and while the file may never move from its location for an application to perform a process or have a user access it, there are also processes that require the file to transfer between application servers and storage locations. There are different layers of automation to manage these processes and handle the file movements. Metadata, which is discussed in detail in a later chapter, plays a crucial role in all aspects of the IP and file-based architecture. In studio production, metadata is the control layer integrating all the devices. It triggers the automation systems, It manages the studio in a box and provides the tracking information for the camera, robotics, and virtual sets telemetry. The control or structural metadata from the automation system will be associated with the stream or file and includes all the content elements, control activities, as well as the administrative metadata, usage rights, permission, tracking, and descriptive metadata. Let me use a video clip to explain metadata and automation in Premiere Pro.
What's up everybody, Jason Boone here from PremiumBeat.com. Today I'm going to teach you all about the power of metadata and how it can help you stay organized and streamline your workflow in Adobe Premiere Pro. So let's get started. So first of all, what is metadata? Well, metadata is descriptive information about a file. Now, both video and audio files already contain a certain amount of basic metadata information, such as the file name, the type, the size, the path, location on your hard drive, the date, and the media duration. And you can add metadata information to clips using Premiere Pro's metadata panel. Now, if you work with a lot of media assets or you work with a group of other editors or both, metadata can really help you out immensely. By adding information to video and audio assets, you can quickly and easily find the information at a later date with a simple keyword search. So let's take a closer look at how to use metadata in Premiere Pro. Now, to work with metadata, we need to simply open the metadata panel, which if you go to Window and select metadata, it will launch the proper panel. Now, if you want to work in a metadata or meta logging workspace, Premiere has a default workspace already set up. So go to Window, Workspaces, and you'll find a meta logging preset right here. You select that, you can see if you're doing some serious metadata or meta logging, you can use this workspace to your benefit. And I'm not going to use this, so I'm going to keep our standard workspace here. I'm going to go back and select Editing. So now that we have the metadata panel opened up, you're going to notice a few things. We have three main sections here. I'm only going to focus on the top two here, clip and file. Now, clip and file metadata are slightly different. Now let's take a look. If I select a clip here, that'll populate our metadata information here. First, let's look at clip. So clip metadata is specific to your Premiere Pro project. It's going to show you all the metadata, and if you add any information here, which it looks like I already added a clip here, or some text here, but if you add any kind of text in any of these fields under the clip metadata section, it's going to only save it within your Premiere Pro project file. So it's Premiere Pro specific. Let me close this. Now the difference here, if we look at file, let's open up file, and you're going to see there's a few different things here. Let's open up some of this. Now file metadata is different from clip metadata in the fact that anything you add here is going to save it in what they call XMP. So what this does is that saves your metadata information to the actual source file. So when you open up that source file in a different application, you're going to be able to see that metadata with whatever application you're using, as long as it reads XMP data. So what is XMP? Well, XMP stands for Extensible Metadata Platform. So not to get too technical here, this is simply a standard which allows you to use metadata between these different applications and allows the applications to read the metadata. And for the most part, XMP data is stored in your source file, as I said before, but sometimes you have file formats that don't support XMP, and what will happen there is there will be what they call a sidecar file, which is a file with the same name but just a different extension, like for instance .xmp. So if you look back here under file metadata, we have a couple of different sections here. There's three different ones. These are called schemas, and what a schema is basically a group of properties or metadata properties that are specific to a certain kind of workflow. And you can really customize these to your liking. And if you want to customize them, you can go up to the metadata panel menu here and select metadata display. That's going to launch your metadata display dialog box. And if you look here, there's just a crazy number of schemas here that we can add and even customize. We could even drop down our basic and take away certain properties if we'd like, really customize it. And then even on top of this, we can add properties and create our own metadata display, even save out a custom setting or a custom schema, but we're not going to do all that. We'll just add a couple of different things here. Close this, see if there's anything that we really need here. Let's just add one other thing. Let's add like a Photoshop. Say we have some Photoshop files in there. And if I just mouse over, it's going to give you some information about each schema. The schema specifies properties used by Adobe Photoshop. We have rights management, media management. So again, there's a lot to choose from. Depending on the kind of project you're working on, will allow you to really customize your metadata display. So if we click OK, now if we look under the file section here, you can see it added our metadata information, which we can go through and adjust accordingly. Okay, so now let's go ahead and add some metadata to a few clips, and then I will show you how you can search those clips using that metadata information. So let's say we had, we had a shoot at Las Vegas Motor Speedway here. We have a bunch of clips that were shot by 2 different videographers. So let's say we just imported all this in, and we want to go in and add the name of the videographers to each clip, so that later on when a producer comes in and says something like, hey, I need all of the clips that you shot, like he'll come to me specifically and say, hey Boone, I need all of your clips, blah blah blah, or I need all the angles, because let's say I was in the middle of the racetrack and he says I need all the angles of that clip or of that camera where you were at. So I can go through, and let's say it was just a few specific shots here that were my specific clips. So if we go into Dublin Core here, I can just go through and add my name under the contributor section. Let's see, 8, 9, and I'm kind of doing this. There's no specific, I'm just saying that I did a couple of clips here to show you how the filtering is going to work out. I didn't actually shoot these specific clips. Okay, so I added to, like you saw, clip 8, 9, and 1, I added my name to. So now let's say there's another videographer here that shot 14, 15, and 16, and his name is Brian. 14, 15, and let's say like the last clip, way down here. There's Brian. Okay, so now the way we can search this is if you look over here in our project panel, we can click over here, and then if I just type in Brian, it's going to immediately filter out, and it says right here in parentheses filtered, and it's showing us those 3 clips that we added the metadata information with Brian's name. And if I cycle through them here, you'll look in the metadata panel, it's bringing that information up. So I can X that out and then type in my name, and then yeah, there it is. It says filtered, and it's got the clip 1, 8, and 9. So you can see if I were to add a plethora of all kinds of different metadata information, it makes this very searchable by all these different keywords. And this is a great job for, like, say, an intern or something, but you would want to use that meta logging workspace at the beginning. As soon as you import your clips in and you name them, you can go through and type in a bunch of metadata information, which if you do the work up front, it's going to make your editing job much more streamlined and easy. And the last thing I want to show you is within the project panel here. I'm going to go ahead and full screen this project panel. Now, if you look over here, as I showed you before, there are these columns, which are the metadata display columns. And again, we can customize this. So if I go up to the panel here and select metadata display, just as within the metadata panel, it'll bring up the same dialog box. And then whatever properties and schemas I select here, it's going to add these as columns. And then I can even, again, save out a custom metadata display for my project panel, which again, I could take everything out of here and just have my contributor or videographer column. So then we could automatically, we don't even have to do a keyword search. We can just search by this column and arrange by alphabetical by that column. I mean, the possibilities are really endless. So again, if you're working with a lot of editors or you're working with a lot of assets, metadata can be a really powerful and just a great tool for your team. I hope you enjoyed the tutorial, and be sure to check out Premium Beat for high quality, royalty-free music and sound effects for all of your media and video projects.
Let's summarize what you've learned in this session. In this part, you learned what is studio automation, and then we looked at type of media workflow, media proxies, media management, and finally how to work media workflow and metadata with together. I'd now like to move on to the next part and talk about Playout, and we will end this session. Products from companies such as Quanto Paintbox and Harry and Rebecca's video systems A42, A60, A62 and A64 would become commercially available in the 1980s. Rebecca's first product introduced in 1982 was the A42 digital video still store. The product, generically called just a still store, recorded and played back still video images with an associated key signal for use in live broadcast operations. The A62 digital disc recorder was dubbed the world's first digital video recording machine with a built-in real-time digital video key. Various other digital tape-based and disc-based products were introduced in both component digital the D1 format described through ITUR BT601 and composite digital D2 formats. These devices gained acceptance within the broadcast production marketplace around the beginning of the 1990s. However, the industry faced a problem. People needed more storage capacity. Moving video consumed a lot of data in D1 or D2 forms. Reliable, large capacity hard disk drives in the mid-1980s were still rare and very expensive. Modern storage systems, even remotely similar to today's storage area networks, SAN or network-attached storage NAS, were still years away. Large-scale video playout systems with record or playout times in excess of 200 seconds were far too costly to implement. Thus, to increase the amount of video storage, video compression technology would have to come to the rescue. The high-performance, high-bitrate compression technologies taken for granted today were still in the laboratory stage and slowly making their way through the standardization processes.
In einem unscheinbaren Bürogebäude in Unterföhring begann im Juli 1996 die Geschichte des digitalen Fernsehens in Deutschland. Mit DF1 startete der erste volldigitale Sender und die APS strahlte die rund 40 Pay-TV-Sender aus. Dabei ging es zunächst noch ziemlich analog zu. Die Bänder mussten noch manuell in die Maschinen gelegt werden und zum Uplink auf den Satelliten genügte ein Container im Hinterhof. Ein vollständiges Monitoring der Sender konnte die APS gar erst ein halbes Jahr später anbieten. Mit der Fertigstellung des Teleports mit 7 Satellitenantennen und dem neuen Kontrollraum begann eine neue Ära bei der APS. Erstmals waren alle Steuerungssysteme in einem Raum vereint. Ein Operator konnte 32 Kanäle überwachen. Mittlerweile betreute die APS bereits 60 Sender. Für die Sendeabwicklung mussten die Mitarbeiter die Bänder auch nicht mehr per Hand einlegen. Das übernahm jetzt ein Roboter. Erstmals kamen auch Videoserversysteme zum Einsatz. Dank der neuen Live-Regie konnte die APS ab 1999 auch Multi-Channel-Live-Sendungen wie die Fußball-Bundesliga, Formel-1-Rennen oder die Olympischen Winterspiele aus Salt Lake City komplett steuern. In den nächsten Jahren baut die APS die Zahl ihrer Kunden weiter aus und betreut Ende 2005 über 100 analoge und digitale Kanäle. Ein neuer Kontrollraum ermöglicht die automatische Überwachung von Videosignalen. Premiere startet mit der APS in die HD-TV-Ära und die ersten Sender speichern ihre Programme im neuen digitalen Archiv der APS. Um die wachsende Zahl der Kunden weiter effizient betreuen zu können, beschließt die APS 2007, ein neues Technikzentrum zu bauen. Es bietet ausreichend Platz für Erweiterungen und vereint modernste Broadcast-Technologie mit einem in der Medienbranche wohl einzigartigem ökologischen Baukonzept, bei dem energiesparende Geothermie- und Grundwasserkühlsysteme zum Einsatz kommen. Mit dem neuen Playout-Center ist die APS gut für die Zukunft gerüstet, um international für und mit den Kunden zu wachsen.
Nowadays in broadcasting, channel playout is the generation of the source signal of a radio or television channel produced by a broadcaster, coupled with the transmission of this signal for primary distribution or direct-to-audience distribution via any network. Such radio or television distribution networks include terrestrial broadcasting, analog or digital radio, Cable networks, satellites either for primary distribution intended for cable television headends or for direct reception. DTH-DBS, IPTV, OTT video, and point-to-point transport over managed networks or the public internet, etc. The television channel playout happens in master control room or MCR in a playout area, which can be either situated in the central apparatus room or in purposely built playout centers, which can be owned by a broadcaster or run by an independent specialist company that has been contracted to handle the playout for a number of channels from different broadcasters. Central casting is multi-channel playout that generally uses broadcast automation systems with broadcast programming applications. These systems generally work in a similar way, controlling video servers, videotape recorder devices, flexicards, audio mixing consoles, vision mixers and video routers, and other devices using a serial communications 9-pin protocol RS-232 or RS-422. This provides deterministic control, enabling frame-accurate playback, instant replay or video switching. Many systems consist of a front-end operator interface on a separate platform to the controllers. The Windows GUI will present a friendly, easy-to-use method of editing a playlist, but actual control would be done on a platform with a real-time operating system such that any large-scale playlist amendments do not cause delays to device control. Most broadcast automation systems will have a series of common device drivers built in. For example, Sony VTR Control, Loud Video Disc Control Protocol VDCP, a proprietary communications protocol, General Purpose Interface GPI or Grass Valley Group N21 Master Control. This ensures that a broadcast automation system bought off the shelf will at least be able to ingest and play out content, although may not be able to take advantage of more efficient methods of control. Most server, and especially most digital on-screen graphic and character generator or CG manufacturers will have a specific device driver for their device, with increasing degrees of complexity, and different automation companies will include these drivers to enhance their product or to fit a customer's needs. This is the traditional method of playout automation, where there are multiple devices. Some modern automation systems use a unified playout method, where the broadcast server fulfills the functions of multiple devices as a self-contained system, like the Playbox technology channel in a box.
Hi, my name is Marco. I'm Video Projects Manager in Axel Technology, and today I'd like to talk to you about our TV Turnkey MCR. MCR stands for Master Control Room. That's the room where normally broadcasters, TV broadcasters, decide which program to actually put on air. It's targeted to television stations that want to go on air on satellite, terrestrial TV, cable TV, or also for web TVs. At the center of our MCR, we have a Blackmagic ATEM 1ME Production Studio 4K. This is actually a video production switcher, but since it has the capability to manage also embedded audio in an audio follow video mode, we can use this as actually a master control switcher. It has 10 SDI inputs, which are pretty good for a normal setup. If you need more, we can enhance that to an ATEM 2 or an ATEM 4 model, which has 20 SDI inputs, and it has 2 HDMI outputs. One incorporates a nice multi-viewer, which gives you a preview of your sources. Very nice the fact that you have view meters also on the multi-view. And then another HDMI output is for your program output. So you can connect any consumer big screen LCD. In this case, I have 249 inches. It also has an analog audio output, which is kind of nice. We have connected it to a Behringer audio mixer, so it allows you the possibilities to pre-listen to your audio connected to loudspeakers. The video mixer, the MCR switcher, also enables you to de-embed the audio from any of the sources and actually allows you to listen to any source before going on air. The ATEM 1 is actually controlled by a remote surface controller. We tend to put a less expensive model than the original Blackmagic model, which comes from J.L. Cooper. This is the Proton, and essentially it's used in emergency situations when you need to switch very fast to a new source. Why? Because usually the ATEM is actually controlled directly by the automation playout. In this system, the automation playout is an Axel Technology product called XTV. It's very interesting because it's actually a true video server. So it will provide you one program output, one preview output, and you get an extra output for the Xtrimmer, which allows you to do quality control over your files. And then we have an input to the same automation product, which provides the possibility to ingest and capture eventually your live programs, maybe to reschedule them on the playlist as a rerun. The XTV automation is actually a channel in a box, and it has 4 terabyte, two 4 terabyte drives inside, and mirror mode where you can store your media. Also connected to the ATEM is our DLG Plus, which is our channel branding solution. It's much more than a logo generator. It allows you to put on air very sophisticated graphics, and this is connected to the ATEM switcher in a key and fill connection, which is very professional, so it allows you to use downstream keying from the mixer to actually put that on air. So we're using 5 inputs. This means that with this model you have 5 more inputs to connect your external live sources. What are those? Those are video feeds coming from in-the-house studios, can be satellite links or any type of live feed which you can decide to actually put on air. Included in the system we have a logging solution. It's usually used for legal purposes, legal certification. It actually captures and records in low quality all the video which is broadcasted, and it keeps the recordings for more than 90 days. It has a nice calendar application which allows you then to go and search the recording that you want to view. Another component in the system is an Axel-made product, which is the Falcon TV. It's an audio processor with SDI input and SDI output, and it manages the audio level. It actually has loudness control, so it actually has ITU 1770 algorithm built inside to level out your audio. Last component of the system is our on-air clock display, and it's connected to a GPS receiver, and it keeps perfect time synchronization, also for all the computers connected to the system. This is a solution that we usually build in the house in our laboratory. We pre-cable it, we number each cable, we do the burn-in and we test it, and then we ship it. We like to think that this is a little bit like the IKEA of broadcast. In fact, it only takes 2 hours more or less to set up the system, turn it on, and then just connect your video cable to the transmitter or to the encoder directly to go on air. If you are interested, you can ask for a quote. Just write an email at sales@axeltechnology.com. We'll be happy to serve you as soon as possible. If you want some technical information or you want to see the diagrams just to see how it's connected, we'll be able to help you with that. Thank you so much.
Playout will usually involve an air chain of devices which begin with content, typically stored on video servers, and ultimately an output, either as an asynchronous serial interface ASIP or serial digital interface SDI for on pass to a distribution company. The devices in the chain depend on the service required under the contract with the channel. Typically, a standard television channel would require a master control, video switcher, or a video router to allow switching of live sources. This video switcher may include other functions such as keying graphics, also known as downstream keyers, audio overs for mixing in voiceovers or announcements, and facilitate transitions between events, such as a fade-through black or crossfade, also known as mix. Other devices include graphics inserters, subtitling inserters, audio servers, aspect ratio converters. Managing the growing complexity of playout automation and file delivery is an increasing challenge to broadcasters. As the number of channels and platforms a broadcaster delivers rises, controlling that infrastructure is critical. Delivering a channel is complex, with many interconnected elements costing money, requiring management and needing maintenance. Enterprise Media Server simplifies these challenges by supporting multiple channels with multiple features in a single box. Playout is the next step in the evolution of broadcast automation and video servers. Gone are the monolithic black boxes, replaced by TCP, IP network-attached real-time service appliances. Playout provides a broadcast automation front-end and a real-time video server for SD, HD, UHDN, or 8 Kelvin in an integrated software suite, offering unparalleled flexibility by playing compatible format and mixed resolution content as well as unrendered edit sequences straight on air. Deploying enterprise Playout on a server brings encoding, watermarking, and CG channel branding to one integrated software solution. Multi-channel Playout is a system for media player component automation. It is a master control room solution that drives a broad range of video servers, graphic engines, routers, and switches to play out a full 24-hour broadcast or a streaming channel. Multi-channel Playout can be configured in a box integrated with ingest server, capture, and real-time 3D rendering engine for a complete ready-to-air broadcasting solution. We will discuss these workflows in a separate video. Multi-channel Playout Sequencer is the front-end graphical user interface that allows you to sequence videos, commercial breaks, secondary events for graphics, insertions, and control going to live and back. It displays the rundown, both in a vertical list as well as a horizontal timeline. You can import this rundown from an upstream traffic system, or just create it inside Channel Maker by dragging and dropping items from the available media. When in addition to the primary list of videos, Sequencer controls all graphic insertions through secondary events, you can add a secondary event. Let's say a graphic insertion by dragging the template from the available graphics directly into the timeline and adjusting its in and out points. Graphics like you are watching now next or program guide can be fully automated. Graphics like you are watching now next or program guide can be fully automated. Multi-channel Playout is semantically aware of the content that plays out and can be configured to fetch the program's title or other metadata that has been fed through the traffic system or directly through MAM integrations. Multi-channel Playout also lets you drive any graphic manually and take it to air whenever you need. You can call up a graphic template, fill in the form with the required information, and take it to air without having to schedule it in the rundown. Multi-channel Playout Sequencer provides continuous feedback on the rundown, identifying and reporting on several key issues. It may have missing media overlaps or gaps, health checks on external equipment, media checks on the actual media, and validity of virtual in and out points are examples of such checks. Custom project rules you may have for your channel for not playing out a liquor ad before 10 p.m. can also be added to the project layer. It also keeps tabs on how long you have until important operator-driven events, countdowns, identify time to next air, time to next live time until the end of the rundown. Also, you can pick an item from the timeline that is relevant to you and get a custom timer to that. Multi-channel Playout is the subsystem that actually drives the media server and graphic engine, and can be ganged in multiple redundant configurations, such as 1+1 or N+M, more typical in a format, including H.264, H.265 seconds, MPT 2022-6, 2022, 721, 10, and others.
Streams, camera cards, satellite, studio, bonded cellular, edge devices. the ever-increasing array of video sources challenge news content providers of every size. Avid's unified ingest and playout solutions make it easier than ever to get media from the field to the screen. You can begin editing within seconds of the feed starting in Media Composer or Media Central Cloud UX. Work with real-time generated proxies if you need to, and transfer the finished high-resolution stories to the studio. That's because Avid's ingest and playout devices are a key part of Media Central, a fully integrated system bringing together story writing, editing, logging, graphics, multi-platform research and distribution, all underpinned by Nexus shared storage for a seamless workflow experience. Media Central Stream is a new addition to the portfolio. Software-based and deployed on-premises or in the cloud, it easily handles the most common streaming formats of SRT and RTMP to get media to your team, to turn around stories faster than ever wherever they are. FastServe Ingest enables both SDI and SMPTE 2110 video over IP recording. Got media on camera cards or removable discs? Then Media Central Ingest, with its templated ingest profiles, defining key tasks such as naming conventions and folder structures, is what you need. And all of the Avid solutions enable that key edit while capture workflow, so users can begin crafting their stories quickly, such a key requirement in any newsroom. Once the team have got things ready, they can send their finished items to FastServe Playout to broadcast their packages through the studio. Avid's ingest and playout solutions are designed, tested and certified for the highest performance. Putting it simply, they just work.
For more information about Playout and Video Server, look at Synergy Playout and VSN Playout and etc.
Cloud Playout. Broadcast technology has now evolved to the point where it's possible to deliver linear and non-linear content from the public cloud. In this video, we cover the following topics that you should consider when evaluating cloud systems for content delivery. 1. How has technology evolved to facilitate content delivery from the cloud? 2. What do we mean by a cloud deployment? 3. What are the practicalities of moving to a cloud deployment? 4. When and how and what should you move to the cloud? 5. What are the advantages and disadvantages of a cloud deployment? Until quite recently, a linear playout chain was built from separate pieces of dedicated hardware. General-purpose computers were not powerful enough to execute the millions of operations required to process uncompressed video and audio streams in real time. A broadcaster could choose the different components from a wide range of manufacturers, sometimes called a best-of-breed approach, and would expect the chosen automation system to control them and make them work together in a seamless manner to deliver their required output. Video and audio were connected together with an SDI cable, and control used serial or Ethernet cabling. A playout chain built in this way is expensive to buy, build, and maintain. Each supplier would have their own service agreement, and if there was a problem, it could take some effort to identify the root cause and seek help from the correct supplier. It's neither flexible nor quick to change. Channel in a box, or a few boxes. As general-purpose computing power increased and became more affordable, it started to become feasible to implement certain functions of a traditional playout chain in software. This change enabled the introduction of a channel-in-a-box playout devices, which were able to collapse several functions into a single device. However, some specialized functionality, such as sophisticated graphics, DVE, and complex subtitling requirements, would still rely on dedicated hardware boxes. There are probably several reasons for this. 1. The extra computation required for these functions could go beyond what the underlying general-purpose computing platform could provide, leading to dropped frames and disturbance of the on-air signal. 2. Good quality graphics and subtitling are built upon decades of experience and knowledge, so it is very difficult for a channel-in-a-box vendor to develop this knowledge and experience when their history and expertise is more likely to be in video servers or automation. 3. Graphics and subtitling rely on complex workflow processes to originate the content, and these are likely to be deeply embedded and difficult to change. General-purpose computing power continues to increase, and IP standards for video and audio streams are evolving fast. New integrated playout vendors have emerged with deep experience in areas like graphics and subtitling. The hardware devices are replaced completely by software modules. SDI transports are replaced by IP streams. The dedicated hardware is gone, and the complete linear playout chain is pure software. This means that it can be virtualized and deployed in a private data center or even in the public cloud. Further appetite for flexibility and cost saving amongst broadcasters and content owners starts to drive the adoption of software-defined integrated playout solutions. Software-defined has many advantages over a discrete hardware approach. For example, 1. It is more cost-effective than the equivalent discrete hardware, both in terms of initial purchase price and in ongoing service and support. 2. It offers the potential for OPEX, pay-as-you-go, payment models, which could be particularly suited to pop-up channels and disaster recovery scenarios. 3. It is more flexible as broadcast standards evolve. A new IP codec or broadcast standard, e.g. UHD, HDR, can be implemented with a software change, rather than a replacement of multiple devices. 4. It is more flexible if a new function is required. For example, audio watermarking can be added via a software update. 5. It can support flexible deployment models. For example, a vendor might allow a software license to be moved between locations, or from bare metal to virtualized to cloud, without any cost implications. This is not possible with discrete hardware. 6. All the various software components operate seamlessly together. If something is not working as expected, there is only one vendor to call, unless the hardware infrastructure or hypervisor is at fault. 7. It can still offer some of the benefits of the best-of-breed approach by integrating third-party plugins for specialist functions, such as graphics or audio loudness processing. What do we mean by cloud deployment? Cloud means different things to different people. For some, it is a private data center. For others, a public cloud provider, such as AWS, Azure, or Google. Cloud implies a degree of flexibility in terms of how the requirements are matched to the infrastructure, and almost certainly implies virtualized solutions and remote operation. A private data center, whether owned by the broadcaster or a third-party service provider, usually offers more flexibility in infrastructure than a public cloud provider can offer. For example, it may be possible to install dedicated hardware equipment. For example, encoders and multiplexers, uplink equipment, or even some SDI infrastructure if needed. A public cloud implementation is rather different. There is no possibility of changing the infrastructure, so the solution must be able to work within the constraints of the specific cloud provider's offering. Those constraints are likely to include network does not support multicast or broadcast packets, may preclude the use of PTP timing. Unlikely to be feasible to use uncompressed video processing and routing, although this is starting to become available at some public cloud providers, specifically AWS. No guaranteed uptime or service level agreement. From this point on, we will be focusing solely on public cloud rather than private data center deployment. Why might you want to use the public cloud or not? There are many reasons to do this. 1. It can be purchased on a usage basis. No need to invest upfront in hardware. 2. Content is delivered to the consumer via CDN/public internet, so originating in the cloud makes sense. 3. capability is not required all the time, so don't pay for it all the time, e.g. disaster recovery or pop-up channels. 4. It's scalable up and down. If new capabilities are required, then additional cloud infrastructure can be added, then shut down when no longer required. 5. Flexibility. If more features are needed, then a more powerful virtual instance can be launched without having to replace the physical hardware. 6. Flexible in geography. Where data is stored or where taxes are paid may be important, but you may want to regionalize to originate some content more locally. 7. Adding functionality to a channel configuration or starting/stopping new services can all be done very quickly, often in less than a day. 8. Lastly, use of public cloud offers potentially seismic change to operational practice, which may present an opportunity to streamline other parts of the operation, even if they are not moving to the cloud. However, there are some disadvantages. Probably the biggest one is cost. Certainly for 24/7 channels, a cloud deployment will cost more over a 3-year period than hosting the equivalent infrastructure on your own premises. It's also not that easy to calculate the cost of using public cloud. Some costs are based on data throughput, some costs are purely based upon time usage, and others are based upon number of accesses to a particular function. There are other reasons why you might decide not to use public cloud. For example, you rely on specific functionality in your Playout chain, which is not available for use in the public cloud due to architectural or licensing constraints. Your preferred vendor does not support cloud deployment of their solutions. You don't want to be locked in to a single vendor. Your team does not have the necessary skills and knowledge to deploy and operate a cloud-based solution. Legal restrictions prevent you from deploying outside your country, and your preferred public cloud provider does not have a data center in your country. You have concerns over the security and control of content and customer information when deployed in the public cloud. Public cloud infrastructure is optimized for traditional IT tasks, not real-time processing of video, audio, and metadata. What do you need to consider when deploying in the public cloud? Having considered the pros and cons of public cloud deployment, you need to consider the commercial and technical practicalities of implementing a cloud-based playout. There are different ways of using public cloud infrastructure for your playout. Broadly speaking, you can treat it as an IaaS, infrastructure as a service, renting the infrastructure from the cloud provider and being responsible for software installation and operation yourself. Or you can purchase a fully managed service through a third-party vendor who themselves purchases the infrastructure from the cloud provider. Many traditional playout service providers, and also newcomers to the market, offer managed cloud-based services, and they can provide a simpler, albeit a less cost-effective route into cloud-based playout. But for optimum cost reduction and greatest flexibility and control, running your own cloud-based infrastructure is preferred, provided you have the skills, perhaps in partnership with your chosen vendor, to build and manage it. Other considerations include choice of cloud provider, security and skills, both within your organization and/or the cloud provider, the location of the cloud infrastructure, choosing the right IP standards, content location, monitoring and control, latency, redundancy, and availability of service. Conclusion. Moving to cloud playout is a challenging thought, and there are indeed multiple issues to consider. It's a big decision, and the buzz in our industry over several years tends to excite us in the direction of wondering whether it is worth it. Is it possible? Yes, for sure it's possible, and there are now quite straightforward ways to make such a move happen. But as we know from experience with broadcasting over many decades, while our industry is filled with broadcasters, each and every one has a very different process and way of working. The considerations may be wide and varied, but their path is now clear and can be systematically defined with a careful thought-through plan. Some years ago, a similar decision was encountered when the industry moved from tape-based workflows to file-based workflows. All content, current and historical, had to move to digital files. The flexibility this offered came to outweigh the drawbacks in time, effort, and cost of digitizing vast amounts of content. In the move to cloud playout, there is a very worthwhile stepping stone in the process that helps bridge what could, for some, be too big a leap. Moving first to virtualized software-defined workflows enables broadcasters to take advantage of the more immediate benefits of remote connectivity, flexibility, and future-proofing that software-only applications offer. Moving to the cloud could be considered a separate step, following the mastery of virtualized workflows. The workflows are relatively straightforward to flip into the cloud, leaving the remaining challenge of taking that tape library to its final destination in the cloud, along with the current content. Whether you decide to make use of cloud will ultimately depend very much on your own needs and constraints. Every use case is different, but having a good understanding of some of the pitfalls, challenges, and benefits should help you make a more informed decision.
Let's summarize what you've learned in this session. In this part you learned what is playout and playout automation, and then we looked at playout history and playout components such as media player, graphic inserter, rundown and live and etc. This is the end of the second and final part of this presentation. Thank you all for listening. It was a pleasure being here today. I'm waiting for emails containing your questions and criticisms.